parallelograms, or you were absent, or you were absent-minded, here is another opportunity to pick up on how to do parallelograms, because today we're doing rectangles. And rectangles are parallelograms and quadrilaterals. A rectangle is classified as a parallelogram. It's just a parallelogram that has been straightened, if you want to say. By show of hands, how many of you know what a rectangle looks like? Oh, now I know you're not listening. Let's try it again. By a show of hands, how many of you know what a rectangle looks like? Yeah, I think we just got some that choose not to participate. Okay, you know what a rectangle looks like. You know the semantics behind what makes it a rectangle. I'm going to hold up a piece of paper to give you a demonstration. This is a rectangle, albeit holes punched in it, but it's a rectangle. Okay? What do you notice about the opposite sides of a rectangle? They're the same length. That means equal. So if the top measures 10, then the bottom measures 10. It's as easy as that. Stop making it complicated. It's as easy as whatever the top measures, the bottom measures. Whatever the left measures, the right. I feel like I'm dancing. Whatever the left measures, the right measures. It's the same thing. If I throw polynomial expressions at you, it's like the warm-up. Don't complicate it. What's equal? Opposite sides are equal. So set them equal. Okay? It's the same thing as with parallelograms. It's just the rectangle in a parallelogram has just been tilted. So instead of these nice corners, you've got slants. Y'all with me? I've already lost some of y'all. All right. You're going to go to the yellow flip book where we're going to teach it. Then we're going to go to page 29 that you don't have yet, where we're going to practice it. And it is a daily grade. And it is due tomorrow. And you have flex tomorrow. You need to start it today, work on it tonight, finish it in flex. Get your 100 in fifth. You with me? Y'all gotta grow up, man up, woman up, whatever it is, whatever it takes to get the grade. Look at the flap that I'm on right now. It's parallelograms, right? Yours looks like this. If your parallelogram flap does not look like this, you didn't take notes that day. You need to fix that. Not right now, because I'm moving on, but you need to go in and watch the video and fix it. All of the properties of a parallelogram that we listed on that flap, now please turn to the rectangle flap. Please make sure you are now looking at rectangles. Tell me what you notice about the first 5 properties. Would you please say that louder and prouder? It's the exact same, which is exactly why I said if you can't do parallelograms, or if you didn't get it, now's your chance to get it, because today's the same thing. We do have 2 additional properties to fill in. That's why it's written like this. You will notice it's the same, then there's a line, and then there's 2 by themselves. That's because these 2 specifically pertain to, I'm pointing to it, what? Rectangles. Thank you for filling in the missing word. If you would, please right now, copy your first 5 properties from the parallelogram flap to the rectangle flap. Copy the first 5 properties from the parallelogram flap to the rectangle flap. The reason I'm not writing it on the board for you to just copy down is because I want that brain of yours to think, what did she just tell me to do, and then do it. Okay? I don't want you relying on me, because that's why some people say, well, when I get to the homework, I have no clue what to do. That's because you're relying on me in the room. We got to cut the tie. I'm supposed to be your support system, not your crutch. There's a difference, right? I'll be your crutch for however I need to be at the beginning, but then we gotta get off the crutch and get to. This is coincidental. We gotta get off the crutch and we gotta get in a boot until we're no longer in the boot, and then you're walking on your own with these problems, right? That was totally coincidental. By the way, if you're in that at Christmas, I was in a boot at Christmas. I bought one of those giant stockings and I cut the bottom out and I put it on my boot, and so I was walking around with a big old red and white stocking. It made it really fun. It was hilarious because I was so mad. This thing is so ugly. I made it hurt. All right. Did you write, Ryan, for the love of all things holy, please stop with that noise, because it's like dogs are coming at me. I can hear it, okay? Please quit. I shouldn't have to say that every day. All right, opposite sides are what, y'all? Congruent. They're also what? Did those get switched?
Yeah.
It's all right. Does it matter?
No.
Thank you. Have enough sense to know that it doesn't actually matter what order you wrote those. Okay, and then opposite angles are what? Okay. And then consecutive, which means if you trace the edge, you've touched the two consecutive angles. Consecutive angles are, and what does that mean? They add to equal 180. Okay, and diagonals? Okay, two new ones. You should already know them. Take a second. Let's just see if you know it. Take a second, read the two new ones, and lightly with your pencil fill it in. And let's see if you get it right. Take a second, read the two new ones, and fill it in with what you think. And let's see if you get it right. Remember, the shape is a rectangle. You know what a rectangle looks like. Yes, you do. Think about it. Hold on. All right. Now, everyone should have tried it, hopefully. Let's answer it. In a rectangle, they are all
Right.
very good. They are all right angles. Now, be specific. That means they are what? 90 degrees. So when we say opposite angles are congruent, well, yeah, but in fact, in a rectangle, all angles are congruent because they're all 90. Okay. Diagonals are, now, parallelogram, right? It was shifted. You had a long diagonal and a short one. It's a rectangle. Diagonals are congruent. Now, I don't want to draw all of the marks on the picture because then it's going to get really confusing. So we are only going to put marks based on the two new properties. And that would, some of the marks are already that would be the right angles. All of the corners are right angles. And now to show that the diagonals are equal, I'm going to label it A, B, C, D, and I'm just going to make up a length. I'm going to say that the diagonal is 10. So if one diagonal, in this case AC, is 10, what's the other one? Also 10. Now we need to add two notes. You need to write whatever I write, you write. We need to add two notes wherever you can find space. Look for alternate interior angles new one. Now that it's no longer slanted, it's straight up and down. I want you to look for right triangles. You're going to look for alternate interior angles and right triangles. So we have an example. We have two examples. One of them is just numbers. The other one is with polynomials. Then we're going to go to the practice sheet, and I'm going to work some with you because there's something on the practice sheet that is not in the flip book. So I want to make sure that you see how to do it. Okay. You need two highlighters, two colors, or two colored pens, or two colored pencils. I have some highlighters. I don't have many of the alternate colors. I think people are stealing them. At least there's one more. Anybody? You need two highlighters, or two pens, or two markers. It does not matter. What? Oh. Okay. Don't put that. Another color? Try to share with a neighbor as I'm trying to pass this out that I'm running low. Dang, so you need. Do you want it? Okay. Do you need another color? No. Make sure you return it if you don't mind, because I'm running low. I think people are forgetting. Actually, let's set it right here so I don't forget. One or two? Just one? What color you already got? Okay. All right. You need two colored highlighters or pens. Here's why. Here's what I want you to do. Because of the mess of that one problem yesterday, and then seeing people get so confused when there's too much information in a picture, I want you to color coordinate the information in the picture. We're going to break it down into two parts. We actually should do three parts, but that's too much. We're going to break it into two parts. It's either a side length, or it's in angle. So that's the two colors. We're going to color the angles, one color. We're going to color the sides or the diagonals, the other color. Now, how do you know which one's which? It's as simple as if there is starts with a D for an angle, degree symbol. It's as simple as if there's a degree symbol. If there is a degree symbol, it's an angle. Chance, what's up? Oh, I only have a green. Your neighbor has an orange, and she has colors. You'll toss that one back to me. Sorry, I didn't think about the paper being. I'll try to remember next time to not do yellow. I'm highlighting my angle, one color. Do I have any more angles given in the picture? No. So I'm going to my other color and I'm highlighting my side lengths, or when I say side length, it doesn't mean it has to be a side, it could be a diagonal. Now do you see that those are two totally, it's like apples and oranges. You ever heard that expression? They're not the same, they're apples and oranges. That's like oil and water, they don't mix. If I see your paper and you have, red means wrong, don't write this. If I see your paper and I see something like this, I don't know, and you've set it up, it makes me think you're either not paying attention or you're not wrapping your mind around the fact that one of these is an angle and the other one is a length, right? Which means, can they be in the same equation? No. I'm going to say it again. Can they be in the same equation? No. So if you will compartmentalize in the picture your information, then you don't accidentally mix oil and water or apples and oranges together. Does that visual help a little bit? Yes, thank you. I appreciate it. I was trying. Now let's actually solve it. You don't even have to sit here and wait for me to solve this. You could start it. A through C. Yeah, remember what I said. I'm not your crutch. I'm just your support system. You lean on a crutch. You're not supposed to lean on me. You're supposed to let me help you when you make mistakes or try to guide you before you make mistakes. What are A, B, and C? What part? Not the numbers. I mean, what part of the picture are A, B, and C referring to? Thank you. These are all, I'm going to write lengths in case it's a diagonal. I really don't know if it is. Those are all length measurements. And what's D, E, and F? Those are all angles. So now you know that the stuff in my picture that's highlighted in purple better not appear. Whoa now. Better not appear over here because these are angles, right? Oh, I think I know. Yeah, and it's on, hold on. Okay. KL.
135.
Ends in letters, which means it's talking about a corner, a vertex. Yeah, N is a point. These are points. You should be done with A. Okay, guys, y'all. Look. Let me see. Yep, you don't have it. Guys, every single one of you do A right now. There is no thinking involved for A. And don't you dare look at a neighbor and tell the neighbor what the answer is. Everybody should have A. Thank you. And B. Honestly, but go A and B right now. A and B. No, this is just a point. This letter means this is point 2. No, the N, this N right here just means this is point N. That intersection where those two diagonals cross is at point N, is what that means. Okay. What'd you get for KL? If you're not done with A and B, then we, yeah, we do. A is what? 35. B. You're thinking the entire thing is 20, so half would be 10. But if you look at it carefully, it's saying that from J to N is 20. So then from N to L would be 20 as well. K to M. K to M. 40. Why? I know nothing about K to N or N to M.
But
Now let's look at angles. Y'all stay with me. Stay with me. Angles. Angles are harder just because you have to trace the letters, pay attention to what angle it's asking, and then you do have alternate interior angles that tend to pop up. K to L to M. K to L to M, and then you find the corner, which is L, and so what's the angle? 90. Why, y'all? What shape is it? So rectangle. Why do they not call them right angles? It's a rectangle. It's 90 degrees. This is 90 right here. LMK. I hope y'all are trying this.
61.
L to M to K. So it's talking about here. Find your railroad tracks. Railroad tracks. Find your transversal. That's in black. 61 touches the railroad track and the transversal. So does the angle it wants. They are alternate interior, so it's 61. Okay, LJM. So hold on, let me get it. JM. So right here. Right? Now, let me guide anyone that doesn't see why it's 29. Let me guide it to you, because this is going to come up in another problem. So let me show you this. And I'm going to draw over here because I have more room. You've got this rectangle, right? You got these diagonals drawn. Yes? This was the goal. This one was the goal. You know, this is 61. Too much. You know, this is 61 right here. You know, the corner itself is what? 90. You know, now mine's not drawn to scale. You know that the diagonals are congruent and they are also bisected, which means because they're congruent and bisected, they're the same all around, right? It's like an envelope. If you think about it that way, it almost looks like an envelope. Can you tell me what shape this is? What kind?
Ooh. Right triangle.
Ooh.
Isosceles.
What?
Isosceles.
Why?
No.
It is
actually
That's one right angle.
What's a right triangle?
Look, right triangle's 90. Look right here. You're just thinking because it's a rectangle has a right angle. But I didn't draw one of the corners. Notice I drew the purple one. I cut into the corner, so I'm not. A right triangle has a right angle in it, which means an angle of 90 degrees every time. Yes. But I'm not drawing the right triangle right now. I was drawing this little one here. Because the diagonals are all congruent and are bisected, it's an isosceles triangle. Macy, JC, they're going to get behind you real quick. How was it? Yeah.
No, you're good.
All right, don't let me lose you so we get more time to practice. So it has how many congruent sides? 1, 2, 3.
Eyes on me.
Thank you. It's an isosceles triangle. Do y'all remember when I said turn an isosceles triangle like a rooftop? And I said that what do you know about the base angles? They're the same. So if you look at this picture, this is an isosceles triangle. I see. Y'all see y'all tomorrow. All we did was finish 1, 2. The video, go to the very end of it and catch the very end of the video. Yeah, it was just one more slide.
Okay, so my homework's due tomorrow?
Yes. Yeah, 1 o'clock. is an isosceles triangle. So this angle they told me to find will be the exact same as this angle over there because those are the base angles, which is why some people said it's 29. So does that help you see now that it's 29? If you didn't see it at first? Okay. Braden, sit up. Stay with me, please. All right. So you might want to make a note somewhere on your paper. Maybe take a pen or something and draw this triangle. Just draw one of them. There are 4 in there, but you don't want to draw all 4 because then it's going to get crowded. Emphasize that triangle with a marker or a pen or something, and then draw your congruent marks. And then maybe make a note with an arrow. Isosceles triangle. When you have a rectangle with diagonals drawn, how many isosceles triangles are there? 4. Just 4. Another question. When you have a rectangle with the diagonals drawn, how many right triangles are there? 4. Flip upside down. Yeah, look at the 2 at the top. There are 4 right triangles as well, which is the example that I need to show you on the other sheet because there's not one on here. All right, go to this one. If PQRS is a rectangle, find the measure of angle QPT. It would really help if you come down to the end of your paper and make a note that you're trying to find the measure of angle QPT. That's the goal, right? I cannot state it by just looking at the picture. I have to find what first? I have to solve for x first. So this is a 2-step problem. Now you have to look at the picture and ask yourself, what's given and what's the relationship? So is it angle or length given in the picture? It is angles, which means, what? What did you just do? I don't think I touched it. Yeah, I don't know how. Did my hair hit the board? Well, what would I have to do? I did. It makes mark. Anything that touches the board, it makes a mark. I know, but I don't know. Something obviously hit it. I know. It's angles. Look, it has a degree symbol here. Has a degree symbol there. So we're dealing with angles. Let's make a note. Okay, now, what kind of angles? Are they opposite? Are they consecutive? Or are they alternate interior? Or are they base of a triangle? What do we have? Alright, so if you're not sure, it helps to take a highlighter. Y'all quit clicking the pins. It helps to take a highlighter and highlight where they're giving you the info. Because then now you can look at it and actually see the relationship. It's a lot easier than having to focus on the arrows. Look for your railroad tracks, right? That's a bad one. There's your transversal. That was the wrong railroad tracks. They didn't touch, did they? Let's do that one. There we go. Now they're touching. Look for your railroad tracks and your transversal. Are they in fact alternate interior? Yes. So let's make a note. Oops. Too far. Here we go. I want you to make a note. Alt, int, angles.
see your mouth.
Okay. So if they're alternate interior angles, you set them. Thank you. 3 people answered me. If they're alternate interior angles, you just set them equal. Thank you. All right, set them equal and solve. Did you get 3? Good. Did anyone not get 3? Now, is the answer 3?
No.
No. Let me use my pen to show you what they want. They want QPT. Q to P to T. They want this angle. Ooh, it's a puzzle. It's a puzzle. Don't say it out loud because I see multiple people that look like they're thinking, which I love. It's a puzzle. They want the black dot angle. We know X is 3. Take a second. It's going to involve 2 steps. It will involve a 90.
But like, you plug in 3 to the 10 as the X.
Did you get, I'm sorry, did you get 59?
Yes.
Whoa. Okay.
No. Eleanor, you're not done yet.
You don't hear that? Just kidding. Okay. Just making sure it's not me. Did you get 59? Yeah, I'm still teaching, so I have to rip off. You can wait for me to get through another example of this. Okay. All right. It is 59. And can you tell me what you did first, just as a group? Plug X in which one? Really doesn't matter, but ideally it would be good to plug it into this one, right? What'd you get? 31. And then what's the corner? Not just like a dice. 90 minus 31 is 59. Keep this paper out. I'm going to hand you the practice paper, and I want to work with you on a couple that did not appear in these notes. I need your highlighters back at the end of class, so please make sure you don't take them.
No, I did not spit on you. You pulled me back. I did that.
Hey, guys, please don't start cutting up because I haven't finished. All right, go to the rectangles paper. You will notice, first of all, this is page 29. You will notice that it has copied all of the properties of a parallelogram on here for you. We just need to add that all right angles and diagonals congruent. Remember Wednesday, he gets here like right after y'all leave. Well, Tuesday was open house.
Monday. What?
Tuesday was open house.
It's wild. Yeah.
Did y'all see my Instagram? I shouted out to y'all kind of.
Yeah,
Are we allowed to follow your Instagram? Is that legal?
Huh?
Is it legal to follow your Instagram?
It is illegal.
No, she said legal.
I thought it was like against the rule that you can't like. I got told it wasn't like elementary school.
Yeah, me too.
But I'm also from Illinois, so can I follow you on Instagram?
Yeah,
What's your
it's.
Instagram?
I follow as long as it's not something that's gonna make me like, ooh, that's awkward.
Or
Like if you're posting cuss words or paraphernalia, you know, I don't exactly. See, that's if it makes me make that face, I'm like, might want to unfollow that.
Okay, put it on the board.
What? Yes, just my name. Anyways, what I was saying was I shared where a memory that came up when Reese was a baby, and last night when I got home, he was in bed, and Brad's like, "You better go in there and tell him good night because he's waiting on you." And I thought of y'all. I know. Yeah.
What is that?
That's what I'm. I know. That's where I'm. That's why I'm helping. I'm doing it right now.
Go.
Okay. Please look at number 1, and please find the first 2. It should be a piece of cake. Which I'd love to have right now, but I don't. So let's just power through it. Please find the first 2. First 2. Nope. First 2. And it helps to label your picture. Okay. Everybody should be good with the first 2. It is the third one that you're probably like, Miss Holcombe, we didn't have one like this. Okay. No, we didn't. All right. Here's where you're going to rely on my colors. Watch. SQ. I'll go with blue. SQ is right here. That's the goal, right? I know nothing about any of the diagonals. Nothing. Would you agree? Okay. What did we say the shape is? A rectangle. And what are all the corners? So what is this corner? Okay. So what is this shape? Oh, y'all should see where I'm going. And I need to know the third side of a right triangle where I know 2 sides.
Oh
Oh.
no.
Why? Let me hear it. What's it called?
Pythagorean theorem.
There it is.
No.
Oh
She shoots. She scores. Yay.
Why?
Okay. Stay with me. Stay with me.
It was annoying.
A squared plus B squared equals C squared. A squared plus B squared equals C squared. It is the Pythagorean theorem. Let me remind you. Of when that's used and how it's used. Pythagorean theorem is a formula that works every time with right triangles. With right triangles, yeah. When you're looking for a third side, when you know 2 of them, and the formula is a squared plus b squared equals c squared. There is a restriction on what letter? C. C has. I'm not trying to rhyme here. C has to be the. Starts with an H. Hypotenuse. The longest side. And the hypotenuse is always opposite of the right angle. So if you look at this picture, the hypotenuse, y'all stay with me, the hypotenuse is right here. It's the blue side. Okay, so let's plug it in. I'm losing some y'all. 24 and 10. They do not matter how they go into A or B. It does not matter because they're getting squared and added. So write it in, 24 squared plus 10 squared equals, now I'm not going to put c squared, I'm going to actually name it by the side. It was s cubed, right? Okay, go to your calculator and type 24 squared plus 10 squared. And it is going to be a large number that you're not familiar with. Now remember, if something's squared, we want to square root. Your calculator has a square root feature. Second square button. You'll notice above it, it's the square root. Why are you not all typing? You should all be typing. This is 676. What do you think about it? 24 times 24. We are square rooting both sides. 676 is actually perfect. It ends up being what? 26. Now here's where I would be careful. You now know SQ is 26. Not careful, I would be smart about this. If the whole thing is 26, then what's each piece? 13. Thank you. And I would label that because it helps you with the rest of the questions. Now that's the only new part with rectangles is if you're dealing with diagonals and you're talking about length, I hope you're listening, you're talking about length of diagonals. Pythagorean theorem is going to come in. Okay? If you're talking about angles, then alternate interior is going to come in. All right, let's go to, let's see, PR, what'd you say? 26, QT, 13. Let's go to this one. What's AC? Y? Yep, 15 and 15. This would be 15 here. What's BD? 30. What's BE? What's AB? There's really no thinking involved here, right? I mean, there's not a lot of thinking involved. BC. Now, this is where find the right triangle, label the two sides you know. Here's BC. Let's go ahead and find the rest of the right triangle. There's the right angle. This is the goal. This is 27. What was the whole thing here? I'm going to write it like right in the middle so that I don't confuse myself. Set it up. We got a squared plus b squared equals c squared. What has to go in c? 30. Right? Doesn't matter what letter you plug 27 into. Does not matter. Now you got to solve for a squared. I would subtract the 27 squared over. You need to know what 27 squared and 30 squared are, and then I would subtract that over, and then I would square root it. Okay, y'all. No, I don't want it. I don't want to do it. It's a two-step problem. You can do it.
Are we supposed to get decimals?
Get this by itself.
Yeah, go to this.
Square them, right? Square them. What's 27 squared? I don't know that one.
Okay, sorry. Positive. Positive.
So you just round up.
No, I think I left mine as radicals. I'm trying to look at I did go to the nearest 10. I want you to write both. So right here, when you go and square root, BC is going to be the square root of 171, which as to the nearest 10th was 13.1. I want you to write both. Because technically, the actual length of it is the square root of 171. It is not 13.1. That's rounded.
Oh, never mind.
It's so much. You're gonna be so far behind.
Ryan.
And we completed a whole of those so
And
far.
hopefully Ryan's front eyes is on You didn't miss that much.
All right. Let's just keep working together because you don't get out till 2:25, and this is due tomorrow. And how many are there? Total, there's 13. I've already helped you on 2. Now you can, yes. That was what I wanted to do. Wait till she gets back. Okay, let's go to the next one. Can you try it?